Last example, we must still find dy over dx. We must still find dy over dx. So now I check, do we have any sets? First thing, no sets. Do we have any fractions for now? We've got no fractions. And by fraction, I mean that do we have x in the denominator? Because we can have fractions like this. This is fine because x is still in the numerator. But if you've got that, that's a problem because x is in the denominator, so you must move x to the numerator and then change the sign of the exponent. But in this case, you don't need to do all of that because you have no sets. Our x is in the numerator, so we are good to go. But now, remember deriving y in terms of x. So before we derive, we must have our equation in the form of y is equal to something. Because we're deriving y in terms of x. So you must first write, we are deriving y with respect to x. So you must first write y, we must first make y to be the subject of the formula here. How do we do that? You will divide both sides by x to get rid of this x here and also divide by x here. What do we get? We get that these two, they will cancel out, so we will be left with y equal to x squared minus 3 over x. If dealt with this problem, if got a fraction or if got x that denominator, you must split this. So it's gonna be x squared divided by x. You will then have minus 3, but then divide by x, which is the denominator, and then we simplify this. Same dividing same basis, just subtract the exponents. So 2 minus 1, we get 1. Here we're just gonna bring x to the numerator. Then we change the exponent of x, gonna become minus 1 now. Then now we can derive, because we have no sets, we have no x denominator, so we can derive. And here you'll get a 1. Here you will get a plus 3 x to the minus 2, which will be 1 plus 3 over x squared. Okay, it's just same way of doing the equations. Sometimes you might need to make y sort of the formula. Sometimes you might need to get rid of sets, get rid of fractions. By that I mean that you must move your x from at the bottom and put it at the top of the fraction. And also you might need to multiply out the brackets. Like in the first example, we saw that what they gave us had brackets like this one. We had to get rid of we have to expand out this bracket. But it's just the same process. And as you do more examples, you get used to these questions. And these are all the ways you could test this in an exam. I can assure you that any question it will ask you, it will be one of these, or you not exact, but like the method that you need to use will be one of these methods that I've showed you, one of these 6 examples, and you can test that if you go to any past paper. But I've got practice problems for you, all from past papers. It's around like 17 questions, and I can say to you, if you can do all of these questions, it'll be good to go, and you'll see if they cover what we have been covering. Like the first one, you've got fractions, you know what to do. Second question, you've got a squared, you know what to do. Here you've got a bracket, so you must multiply out. Here you've got 2 terms. Here you've got sets and fractions, so you know what to do. It's just the same stuff that we have been doing. So I would like you to pause this video and then attempt these questions. So I'm just gonna move through this, so you can pause the video and then attempt these questions. The ones with the stars, they are the challenging ones. So if you're looking to get in distinction in maths, try those ones with the star. But otherwise, others, they should be for everyone to do. So you can pause and then attempt them. I'll see you in the next video. In the next video, we will be looking at we'll be looking at the tangents, basically, in the next video, tangents. And yeah, we'll be looking at finding the equation of the tangents and then and other stuff. See you in the next video.